Algebra 2 students. So tonight what we're going to look at is your first view of complex numbers, and then we're going to look at their operations. So in other words, how to add and subtract them, multiply and divide them. Well, first of all, we have to define complex numbers. And as we're solving quadratic equations, we might come across a problem like this. And so to solve this, we would take the square root of both sides. So take the square root of x squared, we get x. And then we go plus or minus the square root of -1. And then we say, well, what two numbers can we multiply together to get a -1? Well, we can multiply a positive 1 times a positive 1. That'll give us a positive. If I take a -1 times a negative, that'll give me a positive. So I can't multiply two numbers together, the same numbers, to get a square root of a -1. So under the set of real numbers, this would not have a solution. So under the set of real numbers, this equation would have no solution. Well, just like they've done since you were in kindergarten, we started off with a number set. So when you first started, we had the set of counting numbers, so 1, 2, 3, 4. And then after a while, you decided, oh, well, there's a need for a 0. So then we introduced the whole numbers, which included the 0. And then it's like, oh, there are negative numbers. So then we introduced the set of integers. And then after integers, it's like, okay, we have decimals and fractions. So then we went rational numbers. So we keep expanding on the number sets. We keep adding more numbers so to be able to do everything we need to do. Well, that's exactly what's happening here. So from this very thing, we're taking this little concept, the square root of a -1, and we are making a whole number set out of it. And this number set is known as the set of complex numbers. And because this is not a real number, then this unit for this is the imaginary unit. So square root of a -1 is equal to I. And anytime we see a square root of a -1, then we're going to change it to an I. So that means I go back up to this equation, and as I'm looking to take plus or minus the square root of -1, I take out the square root of a -1 and I change it to an I. So these are my solutions in the set of complex numbers. All right, well, let's take a look then at this next screen. So if I have x squared is equal to -13, well, in order to solve this, we would take the square root of both sides. The square root of x squared is x. And when we take the square root over here, we do a plus or a minus sign. And then we're going to break this down. So a -13 is a -1 times 13, just like when we're simplifying radicals. The square root then of a -1 is I. So the square root of -1, we take the square root of this, and that becomes I, but the square root of 13, I don't do anything with, so I keep that 13 underneath the radical sign. Okay, let's move on to the next one. Once again, we take the square root of both sides. We get plus or minus the square root of -9. I'm going to break that -9 down to -1 times 9. The square root of -1 is I. The square root of 9 is 3. So I took the square roots of both of them, so I no longer have a radical sign. I just have an I times a 3. And we will show it as 3i. And then we can't forget about that plus or minus sign. So our solution under the set of complex numbers for this equation is plus or minus 3i. And for the last one, well, before I take the square root, I would first have to move that 11 over. So 3 minus 11 is -8. Then I would take the square root of both sides. So -8, we're going to break it down a little bit more. We see a negative underneath there, so we're going to think of it as a -1. 8 is not a perfect square, but it has a factor that's a perfect square. So 8 is 4 times 2. So we'll take a look at it like this. we can take the square root of the 4 and get a 2. We take the square root of the negative 1 and we get the I. And then we still have a 2 underneath the radical sign. Bring the plus or minus down. And now we have our 2 solutions under the set of complex numbers for this equation. So it's important that you remember this thing again. So the square root of a negative 1 is I. And then if I square both sides, I squared then is negative 1. So write those down someplace again and highlight them, box them in, because we're going to be using that information, shortly here. All right, so let's talk about then what the set of complex numbers is. So a complex number in standard form is a number in the form a plus bi, where a and b are real numbers. So in other words, we could have 4 plus 2i. We could have the square root of 3 minus I. We could have 6 minus I square root of 5. So those are all complex numbers in standard form. So notice in standard form is that if we do have an I, it goes at the end of the expression. And then the part that doesn't have the I is at the beginning. So we want it in the form a plus bi. So they refer to a as the real part because it doesn't have that imaginary unit, that I attached to it, and b is referred to as the imaginary part. Okay, so in 4 plus 2i, so the a is 4 and the b is 2. In the square root of 3 minus I, the a is the square root of 3 and b is negative 1. And in the last one, in 6 minus I square root of 5, the a is 6 and the b is minus square root of 5. Now, I kind of like putting the I before the radical sign. Sometimes you'll see the I after the radical sign, and that would truly be in this form. But the only reason I don't like that, so in other words, something like this, is that some of you get this radical sign kind of long here, this tail on the radical, and it looks like the I is underneath the radical sign, when truly it is not. So that's why I like it in this form. Okay, so complex numbers, they are in this form. Now, an imaginary number then is a complex number where the b is, whoops, I almost lost it there, where the b is not equal to 0. Okay, so a complex number. So in our standard form, a plus bi, the b cannot be 0. So we have to have this imaginary part there. Whereas under the set of complex number, the b could be 0. So you might have 4 plus 0i, and therefore the imaginary part is gone. So that is not considered an imaginary number because that imaginary part's gone. And a pure imaginary number then is where in your standard form of a complex number, the a is 0. So if the a is 0, you don't see this, so you don't have to write it there. So you just see the 3i. And if that real part is gone and all you see is the imaginary part, then it's called a pure imaginary number. Okay, so like 3i would be pure imaginary. Negative 2i is pure imaginary, just an I. So you don't have the real part at all. Now, operations with these are really very simple, and I think you will like doing that. Let's get down to this this page here. So let's start by adding and subtracting complex numbers. Well, to add or subtract them, you simply add or subtract their real and imaginary parts. So you kind of think of them as like terms here. So to add 8 minus I to 5 plus 4i, you take a look at the real parts. So the 8 and the 5, and the operation is plus. So we add 8 and 5. And then we take a look at the imaginary part. So minus I plus 4i. So that's going to give us 3i. Excuse me, I tried to pause it, but it wouldn't pause. So 13 plus 3i. That is the complex number we get when we add those two together. So see how easy that was? We add the real parts, and then we added the imaginary parts. And so you can't add those two parts together. You keep those separate. So it's like a term with an X in it and a term without an X. You don't combine them. All right, for subtracting then, it works the same way. Let's start off with the real parts. So we need 7, but our operation is minus. So we need 7 minus 3. So the real part's going to be 4. And then for the imaginary part, we need negative 6i minus negative 6i. Well, minus a negative makes it a plus. So negative 6i plus 6i cancels out. So we get a 0i, or like I said, it just simply cancels out. So our simplified form is just 4. So remember from the last talk that we, when we were looking at that, some of the definitions on the last page, we said then that this would be considered a complex number, but it's not pure imaginary because there's not an imaginary part there. Okay, the next one. Sometimes it might be easier just to distribute, like if you're subtracting a number, maybe just distribute that negative. So like on this one, what I would do is I'd go 10, and I want to subtract this whole number. So that means it's minus 6 minus 7i, and then plus 4i. Then I look at that. 10 minus 6 is 4. Negative 7i plus 4i is negative 3i. Pretty simple, huh? The next one, we don't have to distribute anything. We're combining. Notice we have 9 minus 6, so that'll give us a real part of 3. And then we have an I plus a 5i. So plus 6i. And for this last one, I have 3i plus 4i, so that's 7i, and then subtract 2i, so that is 5i plus 7. There's nothing else to add the 7 to, so the last thing we'll do is put it in standard form, where the real part comes first, the imaginary part comes second. All right, so that's fairly simple. So you see what I mean? It's not too hard working with complex numbers. Let's take a look at multiplying. To multiply complex numbers then, you kind of do it like you, we started off kind of like we do with, like if we had any variable there, maybe an x. Well, what we would do is we would distribute that. So, for example, I'm going to change this to a 4x times negative 6 plus x. Okay, what we do here is we take 4 times negative 6, so negative 24x, and then we take 4x times the x, so plus 4x squared. Okay, so that's basically what we're doing. There is one more step on this one, however. So we start off the same way, take 4i and distribute it through. So negative 24i, and then plus 4i squared. Well, in simplified form or in standard form, notice it was just a plus bi, not a plus bi squared or ai plus bi squared. So in standard form, we cannot have a power of I. So I have an I squared here. We need to get rid of that. Remember on the screen a couple of times ago, I told you to remember that I squared is a negative 1. So if I squared is a negative 1, I take out the I squared and replace it with a negative 1, and that then becomes a negative 4. So we get negative 24i minus 4. And our last step then is put it in the form a plus bi. So that means the negative 4 comes first, the real part first, the imaginary part second. Take a look at the second one. We have 2i times negative 5i. So when we multiply, we're going to get a negative 10i squared. Once again, there I see a power of I. We're going to take out that negative I and replace it with negative 1. And then multiply, and we just get a positive 10. Okay, the third one. This works similar to what we do if we had an expression like this. Well, what do we do with that to multiply it? We double distribute or we FOIL. So that's what I have to do here with this guy. So I'm going to take 4 times 2. I need to take 4 times negative 3i. I need to take 5i times 2. And then I need to take 5i times negative 3i. So we get negative 15i squared. Okay, so that's no different than distributing, so that's not very tough. I'd look here, and I say, oh, I see a squared, so I can't have that squared. So we take out the squared, and we replace it with so what I'm going to do, I'm going to superimpose a negative 1. That I squared becomes a negative 1. Negative 15 times negative 1 becomes positive 15. And then our last step is to combine like terms. So 8 plus 15 is 23. And then negative 12i plus 10i is minus 2i. And that's already in the standard form then, a plus bi. So we're good there. All right, so you're kind of catching on. So it's not too bad, is it? Here, we're going to double distribute. 3 times 3. 3 times 2i. Negative 2i times 3. And negative 2i times positive 2i. Well, in this case, the 6i and the negative 6i are opposites, so they cancel. So I've got 9 minus 4. I can't have that I squared. I replace the I squared with a negative 1. So I end up with 9 plus 4, which gives me 13. So the i's are completely gone out of that. I don't have any more i's left in there. Okay. And last one, negative 28 plus 21i plus 8i minus 6i squared. Okay, so the minus 6i squared becomes, you guessed it, a positive 6, because you take the negative 6 times the negative 1. Combine the negative 28 and the positive 6. That'll give us negative 22. And then combine the imaginary parts. So plus 10i. Okay, so that's multiplying complex numbers. Before we divide complex numbers, we're going to take a look at dividing irrational numbers because it's similar to that. So when we divide irrational numbers like this, 2 plus the square root of 3 over the square root of 2. Well, to get rid of that square root of 2 in the denominator, we multiply by itself. So if I multiply the denominator times the square root of 2, I also have to multiply the numerator. Because remember, as long as we multiply by a giant 1, we are okay, and that's what we're doing. We're multiplying by a giant 1. So on top then we have to distribute. So 2 times the square root of 2, we're going to leave like that. Square root of 3 times square root of 2 is square root of 6. Those two are both underneath the radical sign, so I leave the radical sign and I multiply the two numbers underneath. Remember the first two, the 2 times the square root of 2, one was underneath, one was not, so I have to leave it like that. Okay, and then our denominator is square root of 2 times square root of 2, which is square root of 4, and square root of 4 is just plain 2. So that's how we divide. When we divide, we cannot have a radical in the denominator, so we just call it rationalizing. So that's how I get rid of that. Okay, so I get rid of that square root of 2 by multiplying it by itself. Now this next one, unfortunately, because the way the denominator looks, 1 minus the square root of 3, I can't just multiply by the square root of 3 and won't get rid of it. So remember, I multiply by its conjugate. So I multiply by 1 plus the square root of 3. Once again then, I have to multiply the same thing times the numerator. Because as long as I multiply a fraction times a giant 1, I don't change the value of it. So in my numerator, I take square root of 5 times 1, and then I distribute the square root of 5 times the square root of 3. They're both underneath the radical, so we keep the radical and we multiply the 5 times the 3. Okay, the denominator. This case, because it's a binomial times another binomial, we have to do the double distribute or FOIL. So 1 times 1, 1 plus the square root of 3, and then I take negative square root of 3 times 1, so I get a negative square root of 3. And then we take negative square root of 3 times positive square root of 3, so we get negative square root of 9. And what is the square root of 9? Oh, it's just plain 3. Okay, take a look at a positive square root of 3 and a negative square root of 3. So those two are going to cancel. And then I have a 1 minus 3. So that becomes a negative 2. So I have square root of 5 plus the square root of 15, and it's all over negative 2. Okay, so that's irrational numbers, and we're going to use that information to help us with the complex numbers when we divide. Actually, I think complex numbers are easier than that. Okay, so this podcast is already 23 minutes long, so let's get through this last slide here. Dividing complex numbers. So, dividing complex numbers is like that last one was. We want to get rid of the radical out of the denominator. Well, we want to get rid of the imaginary, the I, in the denominator also, because it's a radical. It's a square root of a negative 1. So in order to get rid of it, we multiply, like in this one, by I. So that means we have to multiply the numerator times I. So we're going to distribute I then to 7, and then we're going to distribute I to 5I. And in the denominator, we get 2I squared. Well, we change those I squareds to negative 1s. So we get 7I minus 5 over negative 2. And then in the numerator, we want to put the real part first. So there we have it. And if you want it in the true form, A plus BI, that just means that negative 2 goes into both of them. So I have negative 5 divided by negative 2, which makes it a positive 5/2. So that's the A part. And then the B is well, I can make that a minus. It's negative 7/2 I. All right. So there we had a 2i or 3i or something like that. So we just have to multiply by the I. You don't need to multiply by the 2. It's okay to have a 2 in a denominator. On this next one, we want to get rid of the 1 plus 2i. Because it's a binomial, it's got 2 terms, I have to multiply by the conjugate. So this is referred to as a complex conjugate. So 1 minus 2i, the complex conjugate is 1 plus 2i. Alright, so we multiply numerator and denominator. So both of these we have to FOIL. Alright, so in the numerator then, we get 7, we get 14i, we get 5i plus 5i, and then we get plus 10i squared. Alright, so if I simplify that, remember 10i squared, I squared is a negative 1, so times 10, I'll make it a negative 10. 7 plus negative 10 is negative 3. 14i plus 5i is plus 19i. Okay, in the denominator, when we FOIL, because it's the conjugate, the middle terms are going to cancel out. So I'm going to take 1 times 1, and then the 2i and the negative 2i cancel out, so I'm not going to bother writing it down. And then I take negative 2i times 2i, so I get minus 4i squared. I squared is a negative 1, so when I take negative 4 times negative 1, that changes it to a plus 4. So 1 plus 4 is 5. So there we have it. In the form a plus bi, I could write it as negative 3/5 plus 19/5 I. And the last one, we're going to multiply. It's a 2 plus I, so it's a binomial. So I multiply by the complex conjugate is 2 minus I. On top I distribute, so I get 12 minus 6i. On the bottom, we have to FOIL it out. 2 times 2 is 4. The middle terms are going to cancel. Plus 2i minus 2i, they cancel, so I'm not going to write them down. I times negative I is minus I squared. So can you tell me what that denominator is going to be? And if you said 5, you're right. Because I squared is negative 1, so 4 minus negative 1 is 4 plus 1, or 5. So there we have it. Or we can write it as 12/5 minus 6/5 I. Okay. Whew. The last thing I would like you to do is just make sure that you know how to do those problems. So from the book, I'd like you to try your hand at these few problems here. Okay? That way you'll have good questions that you can ask me if you get lost. All right. Good luck with those. And we will see you in class.